Anybody who still didn't take their second homework back? Trevor? Joseph? Gabrielle? Stephanie? Harness? Hoji? And that's about it. Alright. So, no questions?
What?
Meaning of life?
Why is this class so hard?
Well, the reason why you might find it a little harder than normal is because this is the first class in which you go into more depth versus, like the college algebras and the pre-calculus. There's a lot of theory, and the pace of the course is quite fast. You might not necessarily see it yet, or maybe you're starting to see it, but it'll actually, pick up and go faster as we go along. So, okay. Yes?
Since we're going to look at derivatives, what are some applications of derivatives?
A lot of them. We will learn today we're going to start talking about derivatives, and you'll actually learn the first actual geometrical interpretation of derivatives. Let me just give you a quick glimpse into things. Remember we looked at average velocities, right? And then we tried to guess the instantaneous velocity at a particular point. Well, as it turns out, that the derivative of the position function is the velocity function, and the derivative of the velocity is the acceleration function. And those are three functions that you're actually going to see, especially in physics. They're pretty much very standard functions. So, but anyway, that's just one particular thing. As it turns out, derivatives are really, really used. Okay, so. As a first thought, before we get to derivatives, so this is section 2.1. So before we get to derivatives, the first thought would be what are tangents? And tangents are something that we're actually very interested in. And the question is, what exactly is a tangent? Yes?
A line that intercepts an equation at only one point.
Exactly. But we have to be a little precise, and that's usually where the problem kind of lies. The idea is a tangent is a line that touches the graph at a particular, or at exactly one point. Okay? Now, if I look at a circle, that's a circle, a tangent would basically be a line that touches the graph in one point and one point only, right? However, the problem is, let's say I look at my function that looks like this. If I look at a tangent at this point, notice that it actually crosses the line at another point. Everybody sees that? And so we have to be a little more specific about how we define tangents. And so as it turns out, the tangent is basically the definition of a tangent would basically be that it touches the graph at one point, but it doesn't cross it. Okay, that's the key idea behind it. So let's see. Can you take a piece of paper out? Put today's date and your name, and pass it along. Since we're running at about 2/3 of capacity, I figured might as well reward people that come here on Friday.
They all draw.
Sorry?
How many people draw since the beginning?
we're still 50. We still have a 50 people in the class right now. And considering we're only 33 in the class right now, 50, 33 out of 50. So, okay. So I'm thinking those of you who are here, maybe you'll get some extra points on that lovely quiz that you all did so well on. What? I haven't finished it, but like for instance, the way I usually grade things, by the way, and maybe I should probably point out the way I grade, because sometimes people would come to me and ask me, well, what did I do? Well, did you actually grade my test? I never actually grade individual quizzes or tests. I'm trying to be as much as I can uniform throughout my grading, so I usually grade like the first page of all the quizzes, then I go to the second page of all the quizzes, and so forth. And so at this point, I don't necessarily have anybody's exact grade, but one of the problems seemed to be, and I noticed that as I was looking at the quizzes, we spent so much time on it talking about that, and yet the majority of people seem to not actually take that into account. There's I think problem number 3, 4? No. It was the one with f of x was given as a fraction, g of x was a linear function, and the question was asked if f of x equals g of x. And the whole point was, if you're asked something like that, chances are the answer is not yes, because then it would be just kind of like trivial. Anyway, we'll get back to that on Monday. We can go. I'll give you back the quizzes, because right now that's kind of pointless to talk about things. So I'll give you back the quizzes on Monday, and then we can go through problems if you want. If there are problems that you don't necessarily understand what you did wrong on them and so forth. Okay, so let's come back to our tangents. So think about the function f of x equals x squared, okay? And what we would like to do is we would like to find an equation of the tangent line to the graph, or to the parabola y equals x squared at the point 1, 1. Okay? So let me try and actually graph this. More or less. So what we're interested in, that particular line, right? Now, the one thing to keep in mind, and I'm saying this now, and I'm going to say it a few more times in the future, because I know a good portion of you are going to write wrong the equations of the tangents when I'm going to ask you the equations of the tangents. The one thing to keep in mind is tangents are lines. Okay? What should we expect as far as an equation to look like? We're either going to look at y equals mx plus b, right? But in reality, the one we're actually really going to be looking at, and I gave you a little bit of a glimpse when we started talking the first week of class, what I'm really going to actually be looking at is y minus y0 equals m times x minus x0. Okay? Do you remember the two equations? Slope intercept, point slope. Why are we interested in the point slope? Well, because tangents are always going to be at a particular point. You give me a point and you come up with the tangent. If I would ask you the tangent at the point 1 and 4, which would 2 and 4, which would be here, then you would have a completely different line. Okay? Everybody understands this? Okay, and so the point is, since I already have my point, what's the point of actually trying to find the y-intercept since I already have my point? And the only thing I need to actually find is the slope. Okay? And today's class is basically going to be related to the slope. That's actually what the whole point of today's class is. How do we actually find the slope of the tangent line? Okay? So how do we figure it out? Well, the problem is we only have one point, right? If we would have any other point on the line, we would be able to use the slope formula, right? The rise over the run, and you can come up with the slope, right? So what we're actually going to try and do, we're actually going to try and approximate things. So notice, if I pick any point on the graph, and I look at my tan line over there, I guess tan was not the best choice of color, since you can't really see it. If I look at my tan line, that's going to be a secant. Everybody knows what a secant is? No. A secant line, not a secant trigonometric function, but a secant line is related to a tangent line. A tangent line touches the graph in exactly 1 point. A secant line touches the graph in 2 points. So a secant to a graph is going to be going through 2 points. So this is what we call a secant. Okay? Of course. Why not?
Does it have anything to do with
It has nothing to do with the trigonometric secant. Okay. So now, how do we actually figure out what the graph is going to look like? Well, notice, and this is. Let me draw again the quadratic function. So what I'm interested in is this line. Now notice, and I'm going to come from the left because it's a little easier to see. Notice that if I actually am to pick secants that start from the same point, but, so the key idea is the following. As this point moves on the graph and comes closer and closer to this point, notice how the lines are actually starting to tilt, and they'll actually get as close as possible to the slope of the tangent line. So now let's see. If I name this point P and I name this point Q, let's say P has coordinates 1 and 1, because we know that, right? And Q will have coordinates what? Anybody can tell me what the coordinates would be? Let's assume that this is just a random number x. X and x squared? Yes? You don't seem convinced. Any point on the graph has coordinates x and y, right?
Yeah.
Well, what is the graph of what is this function? Y equals x squared. So if the point has coordinates x and y, then each point in fact has coordinates x and x squared, right? Does that make sense? All right. So then, what is the slope m of PQ? What is the slope of the secant?
X over x squared.
Not quite. Be a little careful. What's the rise? What's the run?
1 minus x.
X squared minus 1 divided by x minus 1, you say? Or 1 minus x squared divided by 1 minus x? Yes? This is coming back to, I guess, what was this, intermediate algebra or before that? You have 2 points. What's the slope? The difference in y's divided by the difference in x's, right? Okay. So this is the slope of the secant. So then what would you guess the slope of the tangent to be? Y half. Keep in mind, the goal is to travel this line up until I get as close as I can to P, right? Traveling on this line surely looks like the limit as x goes to 1 of x squared minus 1 divided by x minus 1. Does that make sense? Remember I told you we worked with limits. The next step is derivatives. Derivatives are going to be connected to limits. integrals are going to be connected to derivatives. That's usually how things work. Actually, they'll be connected with derivatives and limits. Is this making sense?
That's the answer.
This is the slope of the tangent, yes.
Okay, so we don't get a direct number without variables unless we're given values.
Yes.
Okay.
Does that mean there's a hole actually, one tangent line?
No. Why? Why would there be a hole?
Because
X minus
x squared minus 1 would be x plus 1, and then x minus 1, and then x minus 1 would cancel out.
I don't think that's
This is not the equation of the tangent line.
a slope.
This is just the slope. So let's take the derivative. Let's do the derivative. Let's actually solve this limit. What is this limit? The limit is x goes to 1 of x plus 1 times x minus 1 divided by x minus 1, which equals the limit is x goes to 1 of x plus 1, which is equal to 2. Right? And so my equation is going to be y minus 1 is equal to 2 times x minus 1. Does that make sense? Is everybody understanding this?
How did we get 2 for x plus 1?
X goes to 1. It's a polynomial.
Oh, okay. We plug in the value.
If you really want to be creative, you can use the epsilon delta definition, which I'm sure everybody really loves. Okay, so does this make sense?
Let's do practice one.
This is a practice. No, I'll get to problems. I'm just joking around. Okay, so the one thing I should point out is the following. This is the point slope form. And if you really want to take an extra 10 seconds, you can actually solve it. Because I know you really like to solve it for y, to have it written in the slope intercept form. You're not getting any extra points for doing that. So, as far as I'm concerned, this is the answer I'm looking for. You get to here, you're done. There's really nothing else to do. Okay? Now, let me come back and say one thing here. Under no circumstances, the equation should be y minus 1 equals x squared minus 1 over x plus 1, or minus 1 times x minus 1. Okay? Remember, that was basically the slope of the secant, right? The whole point is, what I'm looking for is the equation of a line, which means here you have to have an actual number. You can't have x's. Okay? And I'm saying this because I'm sure I'm going to see this on a bunch of tests and stuff, because it usually happens. So,
Don't be that guy.
don't be that guy. Yes, thank you. Okay, so let's look at a lovely graph. So let's make some graph that actually is nice to look at. I don't know why would this not be nice to look at, but anyway, let's assume this is point A, point X. So what we're looking for is, here, I'll start writing the definition, and I'll come back to it. So I'll come back to the graph. So I haven't finished the graph. The tangent line to the curve y equals f of x at the point a and f of a is the line, let's name this point P, is the line through P with slope m equals the limit as x goes to a of f of x minus f of a divided by x minus a. Now, why is that the case? So now I want to go back to the graph and actually discover why that's the case. Okay? So this is A, Obviously, this is f of a. And so I'm looking for the tangent at that particular point. Now, if I choose any x, what is the slope of that secant? Because if I can find out the slope of the secant, then all we have to do is just take the limit, and that will give us the slope of the tangent, right? And so the idea is, we can build this lovely triangle over here. So what is this height? Not quite. F of x minus f of a, right? And what is this length? It's x minus a, right? So if you look at the slope, you're thinking about the rise over the run. It'll be exactly f of x minus f of a divided by x minus a, right?
Yeah.
Wonderful. Okay. Now, do you want the graphical interpretation or do you want the algebraic interpretation of things? Graph? Okay. So let's start off with, again, the same idea. I have a, and I have this function that does that. Let's say I go an h unit away from a. So this is a, and the next one is a plus h. Can you tell me what the slope of that secant would be?
A f of a minus f of a plus h.
F of a plus h minus f of a divided by
A plus h over a.
h. Well, it's divided over a plus h minus a, right? This is the distance. This length is h. This height is that, right? Does this look familiar?
Yes.
What do we call these? Difference quotients. Now do you understand why we put so much effort into them? You understand, you just don't care. Okay, so m is equal to the limit as h goes to 0 of f of a plus h minus f of a divided by h. So we can either look at our limit in terms of x going to a, or we can look at it in terms of h going to 0. Does that make sense?
Yeah.
Yeah? Okay. Wonderful. So, let's see. Okay. How about we do a couple of problems and see how we warm up on things here.
Okay.
3 on page 81. I'll come back because we still have a few things to talk about. So I'll come back to those. But for now, let's actually look at one problem. So I have y equals x minus 1 divided by x minus 2. And I'm looking at the point 3 and 2. The problem asks to find the equation of the tangent line to the curve at the given point. So, equation of tangent line. So what do we do? Keep in mind, the equation is of the form y minus 2 equals m times x minus 3, right? We know the point, the only thing we're trying to find is the slope. So the question is, what is m? So now, do you want to do the first method or you want to do the second method?
We do both methods.
Sure, we'll get to the same answer. Hopefully.
It might be different for everyone.
Okay, how about we do which method?
Oh no, I'm lost.
So this is the first method that says as x goes to a, or we can do the second method Okay, eventually I'll get it right. Okay, f of a plus h minus f of a divided by h. So you said you want to see both methods, right? How about we do number 3 with one method and number 5 with another method? That way you get to see both of them. So which method should I do number 3 with? First one? Are you sure?
Yeah, first one.
Okay. So, what do we have? The limit, as x goes to 3, of fraction x minus 1 over x minus 2 minus, what is f of a? What is a?
Is 8 3?
A is 3, so what is f of a?
3 minus 1 over 3 minus 2.
3 minus 1 over 3 minus 2, or you look at the fact that the point has coordinates 3 and 2. The point is in the form of a, f of a. Right? Bless you. Is that making sense?
Yes.
Okay. All divided by x minus 3. So what now? This is your difference quotients. You had 5 of them for the pretest, you had another 3 of them for the homework.
I do have a question.
Yes.
If the 2 is A, why did you put a 3 in the bottom? Because in some calculations. Oh, okay.
Good answer?
I get it now.
Okay. So what is this difference quotient? How do we solve this? Can't hear you.
Yeah, plug in some.
If you put in 3 for x, you end up with 0 over 0. I'll tell you that much. Remember, that's the whole point of the common denominator. So we multiply and divide by x minus 2. So we end up with the limit, as x goes to 3, of x minus 1 minus 2 times x minus 2, all divided by x minus 2 times x minus 3. Right? And the one thing I don't want to hear anybody whisper, let alone, or actually think, let alone whisper, is the fact that x minus 2 can get crossed out.
Oh no.
Oh, I was thinking that.
I'm still doing slow, so that doesn't.
Well, first of all, the only way you can cancel terms out is if you have a product in the top and a product in the denominator. Well, the denominator is factored. The numerator is not. Right? Moreover, the one thing that you should think about is, if I cross this out, I'll end up with x minus 1 minus 2 over x minus 3. Really?
Yeah, X minus 3.
I mean, think about what you started with. That would basically mean that I can just ignore that. Do you understand? Is everybody understanding this? Sometimes in math, it's better to spend a second or two before doing something to make sure you're actually doing it right. Basically, what is the effect of what I'm doing now? Does it actually make sense, or doesn't it make sense? And the reason why I paused here and I said that is because I've seen that happening a lot in your quizzes. Okay, so now we have x minus 1 minus 2x plus 4 divided by x minus 2 times x minus 3. And so this is equal to the limit, as x goes to 3, of 3 minus x divided by x minus 2 times x minus 3, which equals the limit, as x goes to 3, of minus 1 over x minus 2, which is minus 1. Questions?
That's the slope of the tangent.
That is the slope of the tangent line, yes. And so my equation then is going to be y minus 3, 1 minus 2 is equal to minus 1 times x minus 3. Okay? Yes.
So 3 minus x and x minus 3 cross out.
When you're left with a minus 1.
Oh,
And you're left with a minus 1.
okay. But if they did x minus 3,
They'll be just,
x minus 3 would be then positive.
yes. Okay?
Can you explain that again? From 3 minus x to x minus 2 over x minus 3? How do you get to that?
3 minus x is minus x minus 3.
It's the same thing.
Well, take out a factor of minus 1. What do you get? Better yet, multiply them out. What do you get? Minus x minus minus 3, so that's plus 3.
Right.
So when you have 3 minus x over x minus 3, you have minus x minus 3 over x minus 3, so you end up with a negative 1.
You just arrange the factor.
And how do you know that's happening? Well, put in 3 for x. What do you get? You get 0 over 0, right? Which means an x minus 3 has to be factored out. Again, this is what I was talking about as far as difference quotients are concerned. You start with a 0 over 0, so you have to still work until you actually are able to cancel some things, so you don't have 0 over 0, right? That's basically the ultimate goal. Okay.
Will you ever get tricked though and get 0 over 0 as your answer? And like, I know that's not fine, but I don't want to have to say, oh.
Well, whenever you're dealing with slopes of tangent lines, think about the graph. It will have a tangent,
Okay.
right? So you won't necessarily get 0 over 0. Now what you actually could possibly get is a number over 0, which would be a slope being infinite. Best example I can give you is a circle. If you take the tangent at this particular point, you'll end up with a vertical line, which by definition is given to have an infinite slope, right? Okay. Number 5. It says y is equal to the square root of x, and the point is 1, 1. So exactly the same thing as before, we're just looking at a different problem now. So m is the limit as h goes to 0 of f of x plus a plus h minus f of a divided by h. If you're wondering why I keep putting x there, is it won't become apparent until the next section. So I'm so used to doing that, that's why I actually do it. You'll see what I mean. Okay. So then this is equal to what? The limit as h goes to 0 of fraction h in the bottom. What's f of a plus h? Square root of, and a is 1 plus h minus 1 Anybody remembers this?
I think I know what to do.
Like from 2 days ago, anybody remembers this? This is a problem in your quiz.
I think I got that one right too. Now we have to multiply the top and bottom by square root of 1 plus h plus 1.
Multiply the top and the bottom by
Square root of 1 plus h plus 1.
the square root of 1 plus h plus 1 divided by the square root of 1 plus h plus 1. What do we get on top?
2 plus h.
1 plus h minus 1. What do we get on the bottom? H times the square root of 1 plus h plus 1. Right? The 1's cancel. I have the limit as h goes to 0 of h divided by h times 1 plus h minus plus 1. The h is crossed out. So what do we end up with? 1/2. Right? So what is our answer? Yes?
Can you show me how you got the f of a plus h in that argument?
Well, remember, this point is a and f of a.
Yeah, I got that.
Which means a is 1, f of a is 1. So if a is 1, I'm looking at f of 1 plus h. My function square root of x. So whatever I have in this parenthesis, I have to replace x with. Right?
Why do you do that first one, not the second?
Sorry?
You do it for the first at the plus h. You don't go.
Well, I could have wrote it as square root of 1 if you want.
Oh,
But the key idea is, I know that the second point, the value of the 1 over there is f of a. So I just basically pick it up directly from there.
so it still is the square root of 1.
Yeah.
Oh, okay, that's why I'm confused. So it's just 1. So move on with the function.
Okay? Are we done?
Yeah.
How'd you get 1/2?
Well, the h is crossed out, and now you put in 0 for h. So you end up with 1 over square root of 1 plus 1. So you just end up with 1 over 2. So are we done?
No.
What do we have to do? Y minus 1 equals 1/2 times x minus 1. Right? Does that make sense? Okay. Wonderful. Let's move on. So,
Well, wait. You don't want. You want us to complete that?
it is complete.
I know, but like, add the 1.
As I said before,
Doesn't matter.
you can spend the extra 10 seconds to solve it if you really want to write it as mx plus b.
Well, so it doesn't matter to you if we leave it like that? Or,
I prefer it like that.
really? Oh yeah. Okay.
Why would I not prefer it like that? Because I know you guys are always really so much attached to the mx plus b, and I never really understand why. I have my point, I have my slope. I don't have to find an extra thing. I showed you how to graph this from here, right? You start at the point 1, 1, you have a rise over run of 1 over half over 2, that's your graph. You don't really have to go and find the y-intercept.
I guess it'd make it easier if you had the y-intercept to graph it from that point.
What are you saying you can graph?
I can say that I can graph it from here instead of going there. I already have my point, which is 1, 1. I know my graph passes through that point, and I have my slope. What do you do when you have the mx plus b? You start at your b, and you put the m to get your graph, right? Well, I just started at the point 1, 1 instead of starting at the y-intercept. It's exactly the same way. It's exactly the same graph. You just basically, cut out all the algebra. Okay. Velocity. So, as I just was talking about derivatives and everything else, let's actually just make it more or less official. We're going to have the following, and I'm going to go a little different than your textbook does, just because I think it's better this way to actually get used to that particular idea. So the position function is given as y equals s of t. So this is position after t seconds. Okay? Now, I can go through the actual writing out, but the key idea is v of t is the instantaneous velocity at time t, and it's given by v of t is equal to the limit as h goes to 0 of s of a plus h minus s of a divided by h. Whoops. Sorry about that. It's v of a.
Is that a V or an S?
Which one? This is v of a.
Why are we using?
What about the one above it? Is that S?
This is v of t. Velocity. V for velocity.
So V of T and V of A are two separate.
V of t is the instantaneous velocity at time t, and this is at a point A. So when t is equal to a, this is at a particular point. Okay. It won't be until next time that we're actually going to learn about v of t. And this is why I kept putting those x's when I was writing them out, because you can actually come up with something called a derivative that's actually going to be defined as a function, not just at a particular point. Is this making sense? Do I need to spend more time on talking about this?
S or 5.
S. Remember when you looked at average velocities, right? You had it as a homework problem, okay? When you looked at average velocities, the whole point was this didn't exist, right? So you computed all these average velocities and then you said, okay, now let me guess what the instantaneous velocity was, which basically said, can I look in the table and kind of guess where I'm actually going with that? Do you remember that?
Yeah.
Well, that's basically what we're doing. We're just saying directly go to the limit instead of coming up with the table, okay? Questions?
This doesn't really look like a different method. Looks like we're using the same thing to.
Hence why I put so much effort on difference quotients. Because it turns out that they keep showing up a lot. The derivative of a function f at a number a is given by f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a divided by h. So two things happen here. First of all, this is how we denote derivatives, in the sense that we say f prime means the derivative of f. Second of all, notice the right hand side is what? This is the way this derivative is written. There's three different ways you can actually look at a derivative. Okay, there's three actual geometrical representations of a derivative. We already talked about two. First one was the slope of the tangent line. Right? This is the slope of the tangent line. Second of all, and it actually lies above there, is called the instantaneous rate of change. Okay? That's basically the two big ones. Do you understand that?
It's using a slope of the function.
Sorry?
More like a slope of the function.
Slope of the tangent line at a particular point.
We say instantaneous velocity is that kind of slope of a.
Well, if you look at, if you think about it in terms of velocity, that's why we talked about the velocity. That actually will tell you the instantaneous rate of change. That's actually how we think about things. Why rate of change? Well, if you think about the velocity versus the position function, how do you come up with the velocity? How do you come up with the average velocity? You look at the rate of change. You look at how much you actually changed your position basis divided by the time you spent, right? That's basically the rate of change. And so the instantaneous rate of change is because of the limit. Yes?
So wherever the slope is on the tangent coordinates, that's what the rate of change is at that point. Right?
Yeah, well, again, think about what slopes are, if you want, if you wish. Slopes are the rate of change, right? You're actually looking at the change in y divided by the change in x, right? And we used slopes of secants to come up with the slope of the tangent, right? We looked at the limiting factor. So we looked at rates of change, and now we're just saying that it's actually the instantaneous rate of change because it happens at that particular point and not on an actual interval. Okay. Clearly, f prime of a can be written as the limit as x goes to a of f of x minus f of a divided by x minus a. Right? Remember, both of these limits were equivalent. I showed you geometrically because you told me you wanted to see the geometrical part. I can show you the algebraic part, why they're equal to each other, if you choose to. As it turns out, this is the formula we're going to use most of the times. And you'll see why. Again, you'll see why in the next section. Okay. So let's do a few more problems. What are we looking at? Okay, I probably should have spent a little time talking about slopes of tangents and why we're actually interested in tangent lines, because I basically did not actually spend any time talking about tangents and why we're actually interested in the tangents. So let me just actually say that, because I think it's something very important. So let's say you have this lovely function. Technically it's not a function, but anyway. What happens if I look at this tangent? Well, depends on what you want to look at. If I look at, let's say, I look at a window this big. Well, the tangent doesn't really seem to be all that good, because look at the function, it actually goes very much away from it, right? However, if I actually get into that window, it all of a sudden looks like it's a lot closer to each other, right? And if I actually just go right very close to it, and you can play with this at home if you want. If you have a graphing calculator, plug in any function. Think about, I don't know, y equals x squared, okay? And pick some random point on the graph, and keep zooming in, and keep zooming in. Eventually, your parabola is going to look like a straight line. Is that making sense? And that's basically the key idea. The key idea is that my function could be very ugly, but in the neighborhood of this particular point, my tangent line is going to be very much close to my function. And that's actually what we're really looking forward to. Okay? I'm kind of giving it away for future reference, but the key idea is sometimes people do this, your function could be really, really ugly. But if you can come up with the tangent, with the equation of the tangent line, you can use, on that little particular space, you can actually use the equation of the tangent to approximate the value of the function.
What?
And that's something called linearization. And I guess we'll have a while until we get there. But anyway, we'll talk about that when we get there. Okay, so let's see. Let's look at number 15. I think that's actually an interesting problem to look at. And it'll require me to actually graph these. So let's see. Coming from over here, come down. Okay. So the focus for right now is the following. We have the numbers 0, g prime of negative 2, g prime of 0, g prime of 2, and g prime of 4. And you're probably asking yourselves, what exactly are we doing with these? We're supposed to list them in an increasing order. Okay? So, what should we do? Which number would you guess? First of all, let's start off with 0. I'm going to put it in the middle here. Okay? Which numbers would you guess are positive? Which ones would you guess are negative?
G of negative 2 is negative.
G prime of negative 2 is? Positive. Why negative? Why positive?
Because the graph is going up.
Because the graph is going up. Remember, the derivative is also, it's the key idea about this particular problem is to remember the fact that the derivative is the slope of the tangent line at that point, right? So,
Just say that again.
the derivative is the slope of the tangent line at that particular point.
Oh, so slope is positive.
Where x is negative 2, the slope is negative.
Why is the slope negative?
Well, because it's decreasing, it's going back down. It's an unhappy case.
Well, that's negative.
G prime of 0 is going down.
Why am I?
Because I think you're thinking about, have you had calculus before?
Yeah.
That's why. You're thinking about the first derivative test and the second derivative test. That's when we actually talk about graphs as a whole. Right now we're only looking at one particular point. And at this particular point, the tangent shoots up. Is everybody seeing this? Yes? So that means that g prime of negative 2 is in fact positive, right? Which other ones are positive? G prime of 0, or 2, or 4? If you look at 2 and 4, your graph is going up, which means your slopes are also going to be going up, right? So maybe one thing to do is actually write them out. Okay, so that being said, is there one that's negative? Which one? G prime of 0. All the other ones are positive, right? Which one is smaller?
G of 4.
Now my graph is not necessarily as good as their graph.
Wait, how do we know which one's bigger, G of 2 or?
That's why I said my graph is not as good as theirs.
Oh, okay.
If you look on their graph, here, this is actually a little steeper than this.
Oh. Would there be a time when you actually have to solve out like G of 2 and G of negative 2 to see which slope is greater?
You're probably, no, not really. I mean, this is just an exercise in realizing how tangents act and connect to derivatives. This is basically why this exercise was in place. It's not necessarily that you're going to be doing problems of this nature later on. Okay, so let's see. 23 on page 81 says the following. F of x is equal to 3 minus 2x plus 4x squared. Find f prime of a.
Yeah.
Sorry? What is by definition, what is f prime of a? The limit as h goes to 0 of f of a plus h minus f of a divided by h. Right?
So you're actually really giving us a point for this.
It's not a point. Yeah, it's A can be anything. In the next section, what we're going to say is, we're going to say, instead of looking at a particular point, how about we define the derivative as a function? And so, instead of A, we're actually just going to say f prime of x. Which is why this particular form is preferred versus the other one, because the other one already has an x in it. But now if I put an x in for A, I'll have f of a plus x, f of x plus h minus f of x over h, which means I can actually attack it. Okay, so you tell me what it is.
Oh my gosh, they're huge.
This was,
-2 + 8x.
okay, tell me what it is without actually solving it directly, but actually doing the derivative, I mean the limit. Of course there's an easy way.
I'm doing a long write out everything way.
The easy way is going to be coming in like two sections. Remember limits, okay? We had the precise definition of a limit, which meant you had to go through all that, right? And then later on we discovered that there's ways of actually approaching limits in a different way. Well, it's going to be exactly the same way for derivatives. There's going to be a long way, which is basically this, and then we're going to later on discover shortcuts that will give us a lot easier ways to compute derivatives. Okay, so anybody got to -2 plus 8a? Okay, should I do it?
Equal 1?
-2 plus 8a. That is the answer. Probably because you forgot to do something.
Yeah, probably.
What's f of a plus h? 3 minus 2 times a plus h plus 4 times a plus h, quantity squared,
Oh,
minus 3 plus 2a minus 8a squared, all divided by h. Right? Yes? Okay. So then this is equal to the limit, as h goes to 0, of 3 minus 2a minus 2h plus 4a squared plus 8ah plus 4h squared minus 3 plus 2a minus 8. It should be 4a. I don't know why it's 8. I just noticed right now, since I couldn't cancel them. All divided by h. And now 3 and negative 2a and plus 4a squared cross out. And notice that what we're left of has an h in every single one of them, so I can actually factor it out. So I'll have h times, bless you, minus 2 plus 8a plus 4h divided by h.
whoa, wait. I'm looking at 4a plus h squared, and you got 4a squared plus 8ah. What happened?
That is what I told you at the beginning of the semester that you'd better know. What is a plus h quantity squared?
It's a plus h times a plus h.
Or it's a squared plus 2ah plus h squared. Remember what I told you. As it turns out, going in this direction, you can put one next to each other and multiply them out. However, at some point in the semester, you're going to need to know this to come back to that. So, you'd better know it. So now the h is crossed out. Put in 0 for h, and you end up with minus 2 plus 8a.
Is it A or X?
A. Well, we started off with f prime of a. That's what we were looking for. So the answer should be in terms of a. Questions?
So to do it this way, we kind of find a root, almost.
Sorry?
To do this way, we kind of like find a root because you're doing h to 0.
Nope.
No.
What have you been finding a root?
Well, the other way was completely different. But this way, you're relating it to 0.
Well, no. See, again, it's the reason why both methods work is if you come back to here. Okay? Think about why did we write the secant here? The key idea was this distance was getting smaller and smaller, right? Because this point is basically traveling to that point. So this distance was getting smaller, which means x goes to a, right? The alternate way of looking at things is here, where a plus h is going close to a. But this distance just says that the value of h gets smaller, which means it goes to 0.
So we really have a plus a minus a.
Yes. Yes.
With the A and the A plus H,
Uh-huh.
Okay.
is A, f of A, the point of the tangent line?
This point?
Yeah,
Yes. A and f of a.
but the relationship between A and the A plus H is like the secant line?
Mm-hmm. Yeah, remember we talked about secants, and then we said if you take the limit, which means if you make it smaller and smaller, you end up with a tangent. And so this would be the slope of the secant, but this is the slope of the tangent because we have the limit now. Which means our distance is getting smaller and smaller.
Okay, so both methods look at secant.
Yes, before you take the limit. As soon as you take the limit, you're
The secant line, so,
the limit of the slope of the secant line, yes.
yes.
Okay, I'm trying to get the last problem right.
Okay.
That's all we just did. I ended up with -6 plus 4h.
Well, I don't know. Let me see. What'd you do?
-2h plus 8h plus 4h squared. And I took the h out.
Let me see. That's because you forgot your A.
Got my a?
8 AH.
Oh, 8. 8. So we got -2 plus
8A
4h.
plus 4H, right? And what is H?
0. So it's -2 plus 8a.
Okay. So I'm guessing we should do another one.
Definitely.
25 or 27?
Whichever one's harder.
Which one are on the homework?
You have to do all of them in the homework, so. So we have f of x is equal to 1 over the square root of x plus 2.
Is this when you do the low D high, high D low?
When you get to that part, yes. Right now we're only doing limits. Okay, so f prime of a is equal to the limit. By the way, if you do know how to take derivatives without actually using the limits, for the homework, you have to do the limits, otherwise you're just going to get 0 points for those. You can verify that you got the right answer, but you still have to do the limits. And moreover, when you actually have the test and the final, you will have a problem in which you'll actually be asked to find the derivative using the definition, which means you have to do this. It probably won't be an ugly problem, but it still will require you to do that. Okay, so the limit is actually goes to 0 of f of a plus h minus f of a divided by h. I keep writing this out because I'm hoping this way you'll all remember it a little easier if I keep saying it. So now what is f of a plus h? Notice how big of a fraction I opened up here.
1 over the square root of a plus h plus 2.
1 over the square root of a plus h plus 2. Very good. Does that make sense? Minus f of a,
Yep.
which is
Square root of a plus 2.
1 over the square root of a plus 2 divided by h. So what now?
We have to find a common denominator.
What is the common denominator?
Just multiply the right one by 1 over the square root of h.
Does that make sense?
What'd you just do?
Multiply and divide by the least common denominator. That's what you said. Least common denominator was the square root of a plus 2 times the square root of a plus h plus 2.
Square root.
Right?
Alright, I just got really lost.
No. Why? Hold on a second. You said multiply and divide by the least common denominator, right?
Yeah.
Least common denominator is the square root times the square root. Right? So what happens when you multiply and divide by it? Well, the dividing by it just shows up in the denominator, right? What happens in the numerator? Well, think about what happens when I take the two square roots and multiply them by the first fraction. The a plus h plus 2 under the square root gets cancelled with the a plus h plus 2. So what am I left with is just the square root of a plus 2. Right? Okay, so what next? I'll just say this. If you put in 0 for h, what do you think you're going to end up with? You don't have to really actually try and compute everything. 0 over 0? Why do you get 0 over 0? Well, because, again, think about what difference quotients are. You will always get 0 over 0 unless you actually start cancelling things. We haven't cancelled anything so far. All I've done is multiply and divide by the least common denominator. Right?
Wait, so we multiplied it by 1 over the square root of h. Is that what you just did?
Square root of a plus 2 times the square root of a plus h plus 2 divided by the square root of a plus 2 times the square root of a plus h plus 2.
That's what we multiplied the whole thing by.
Yes, that's what you said.
And so that cancels, so that cancels out the 1 on top.
What is this fraction multiplied by this term?
Would be a plus h plus 2. It would just be that.
It'll be this, which is what I have.
Maybe I need to.
Think about this. 1 over y multiplied by y times z. What do you get?
Y over z over y.
Which is z.
Z, yeah.
Well, that's exactly what we're doing here. This is y, this is z.
Okay.
What do you get? 1 over z times y times z. You get that. Yes?
But isn't it square root of a plus 2 over square root of a plus 2 square root of a plus h plus 2? And then, can you just like show it, I guess,
Okay. So what do we get when we multiply them out?
square root of a plus 2 minus a plus
1 over the square root of a plus h plus 2 times the square root of a plus h plus 2 times the square root of a plus 2 minus 1 over square root of a plus 2 times the square root of a plus h plus 2 times the square root of a plus 2 divided by h times the square root of a plus h plus 2 times the square root of a plus 2.
Whoa, yeah, I want to copy that down. That makes sense,
So, okay.
even though it's super.
So we don't, so that even though there's like a fraction on top and then inside another fraction, we don't multiply this other fraction to that fraction.
You guys are funny. When I've done this in the past, there were no problems. As soon as square roots show up, it's like the whole system is broken down. It's exactly the same thing that we've done so far. The only difference now is we have square roots instead of just, linear functions. Right? I mean, look. Where was it? Here. Nobody had a problem here, right? We multiplied and divided by the least common denominator, right? Nobody said anything about where's the x minus 2's over here, right? Does that make sense? All I'm trying to say is, I'm not trying to make fun of you. All I'm trying to say is that you don't have to get scared when you see things. The same concepts apply as before. You just basically have to write out what you're left with. The fact that they have square roots or they're raised to the 1,000th power, it doesn't really matter. In the end, it's just that same quantity that just gets moved around. Okay, so then this is equal to the limit as h goes to 0 of the square root of a plus 2 minus the square root of a plus h plus 2 over h times the square root of a plus h plus 2 times the square root of a plus 2. So, we're in agreement?
Yes.
Wonderful. What now?
I get it.
What now?
If you take out an h squared, the top one, do you do that or no?
No. Why? How would you get an h squared from?
The one on the right, when you just factor out an h squared,
Here?
top.
But we don't have an h here.
What?
You only have an h here.
It's not square.
One over h, like, do that.
Okay,
H squared over a over h squared.
I've seen this again on your homework. On your quiz. Remember when we factored out x's and then you cross them out?
But if we don't add it up,
That only works if you go to infinity. If you don't go to infinity, that is completely and totally pointless. Because 1 over x, as long as x doesn't go to infinity, 1 over x is not 0.
That was only for that last section of the class.
Yes. Okay. So what do we do when we have all these square roots and we end up with a 0 over 0? Multiply by the conjugate. What is the conjugate? Square root of a plus 2 plus the square root of a plus h plus 2
oh boy.
divided by the square root of a plus 2 plus the square root of a plus h plus 2. I didn't say this problem is easy. So now what do you get on the top? A plus 2 minus a minus h minus 2 divided by h times the square root of a plus h plus 2 times the square root of a plus 2 times the square root of a plus 2 plus the square root of a plus h plus 2.
I got a question. How come we get, it changes to minus 2 on the top? Like the right 2 on the numerator.
Because you have a plus 2 minus the quantity a plus h plus 2.
Oh,
If you distribute the minus, you end up with minuses in all of them.
okay.
The A's cancel, the 2's cancel, and I'm going to use green because I don't want to write this again. The H's cancel, and I'm left with a -1 on top. Right? Does everybody see this? So what is my limit? -1 over the square root of a plus 2 times the square root of a plus 2 times the square root of a plus 2 plus the square root of a plus 2, which all becomes as -1 over, what's the square root of a plus 2 times the square root of a plus 2? A plus 2. What is the square root of a plus 2 plus the square root of a plus 2? Times 2 square root of a plus 2, right? Or in other ways, you can write it as -1 over 2 times a plus 2 to 3/2.
Okay, I'm messed up again. What happened to the h in the square root of a plus 2? We crossed it.
There's no more limit.
Huh?
There's no more limit.
Plugged in the limit now? Oh, okay.
Okay? Alright, so we'll stop here. I hope you enjoyed yourselves.